Ladies and gentlemen, we hope we were able to make you curious about our new MyReserve Matrix. In the next hour, we want to talk to you a bit about some of the technical aspects. And then afterwards, our storage experts will be happy to answer your questions. Welcome with me, the Head of Development, Managing Director of SOLARWATT Innovation, Dr. Olaf Wollersheim. Hello there, ladies and gentlemen, partners. Why are we all here today? Mainly, it's because we invited you all to come, and you thankfully accepted our invitation in your numbers. But there's a deeper reason why we're all here today. And I spoke yesterday with my colleague Andreas Skutsch, and we sort of philosophized a bit about what is it that drives us? Why are we all really here today? And I think the main reason and an important aspect is that we all love what we do. And we love our fitters as well. Now, don't take me too literally. I have been married to the same woman for 25 years, so don't start worrying about me. But we really, really do care about our partners. And in every good relationship, there are, of course, questions that we ask ourselves. What do you think the most common reproaches are that you have with partners who've been together for a very long time in a marriage or another relationship? Any tips? You know, come on, what do you get told 2, 3, 4, 5 times a year by your partner? You're not really listening to me. Yep, that's right. That's got to be the top 3. Or you don't really understand me. And this happened in the relationship between SOLARWATT and their customers as well. And we've made a real effort in the last 2 or 3 years to listen very carefully to what you have said to us about your experiences with the storage products that we've given you in the past. And we've made a real effort to understand properly what you're encountering in your work on the ground, because you're really our front line. In the utility rooms of the Republic of Germany, you have to try and make your customers happy, and we're well aware of the fact that we can make this work easier for you or more difficult for you, depending on how well we tailor our products to your needs. So I'd like to tell you a bit about some of the technical aspects of the SOLARWATT Matrix systems and talk to you a bit about some of the feedback we've received from you and try to feed it into our products to make them your products too. Of course, there's a development department, and they designed the product, but an awful lot of smart input came from you. And it's really more your product than ours as a result. Now, one of the things that's important as a sales argument for your end consumers is efficiency. Storage efficiency is debated a great deal, particularly in these days. The German Association of Energy Efficiency has published its guidelines, and the way that we deal efficiently with renewable energies is enormously important. So how can we build an efficient storage system? Well, it starts with the topology. You know that there are AC coupled storage systems, DC coupled storage systems linked to the inverter and DC generator coupled ones. And the MyReserve system is always DC generator coupled. So that means that the consumer gets a PV plant. Of course, a high-quality photovoltaic system with the best guarantee conditions would be the best, and you know where you can get that. You choose the inverter. Everyone's got their favorite product that they prefer. Everyone likes a different product. And then the connection between the PV system and the inverter is where you connect the MyReserve storage system. It's always been that way, and that's the way it's going to be, because that's the most efficient circuitry system. And this concept remains and always will be independent of the inverter. So that means there's no white list, no black list. The storage system can run on with any inverter. You don't need to have a communication cable to the inverter. You don't need to have any protocol, any software updates to ensure compatibility with the inverter or anything of the kind, and you can scale it up. That's something we learned from you. There are many storage customers that you have who come back to you a few months later and say, if I had a bigger battery, then I could increase my autonomy. And of course, they can do that. And then the system has to be such that you can go down into their basement, add a couple of new battery modules, and make your customers even happier. Now, we've measured the efficiency of the system already. So this is the first proof that the thing works. The devices that you see here are not functioning at the moment, and I'm sure the experts here will have noticed that we haven't cabled them up completely, but there are completely cabled up ones, and we've had initial tests on site with customers, and these are some of our efficiency results based on the Energy Efficiency Association, and you can see the level of load charge, and you can see the output and the rated power as well. So if you look at the curve here, it's 5 battery modules here, and the top level is 5 kilowatts in performance. So the point towards the right is 4 kilowatts, and the point to the left of the curve is 200 watts. And what you will find is that for a long period, the charging efficiency is around 95% or higher, depending on the voltage of the PV system that you've connected to it. So the curves differ in the sense that in one case you have a PV 800 volt voltage system, and the other has 375 volts, which is a serious charging efficiency level. And you can see the depth of discharge as well, which is the BAT TOC. And that's because the energy comes from the battery into the AC grid, and this always goes via the inverter. So the efficiency of the inverter is factored in here as well, which is why the figures aren't as high as in the top graph. And here you can see very clearly that we have an excellent efficiency rate, 95%. So you have to imagine these are 2 efficiency rates multiplied, i.e. that of the inverter and that of our discharge electronics. And if you want to get 95%, both of them have to have about 98% each. So we're talking a very, very difficult level to reach, but thanks to our smart electronics designers, we've managed to get this high efficiency rate. And here's another interesting effect as well, that when you have very small power output, the efficiency level goes down up to 80% or lower. And that has to do with the fact that with this test, there was a very large inverter. So if you have an 8 kilowatt inverter hanging in your home, like in this case, and then you try to use cover a very low level of power requirement, 50, 100, 200 watts, then this inverter will have a very poor efficiency result. The storage system can do what it likes, but if the inverter only has a 70% efficiency rate, then you can have 100%, but it's only going to be 70. So it's the weakest link. So you have to go away and think about how you want to design the entire system in a smart way so that you get the best efficiency rates. All the same, we're among the first who can present these measurements based on the energy efficiency guidelines, because they've only been out for a couple of days, and that should hopefully give you some faith in the fact that you have a very efficient product to recommend to your customers. Another aspect that we've also learned from you is that many end users phone you up immediately as soon as in the day they have a situation at some point that they are getting power from the grid. So the ideal storage system ensures day and night that you never have to get any power from the public grid. Now, you all know you can't avoid this completely, 100%, only to a certain extent. But that is certainly the expectation of the end user. I've invested in a storage system, I've installed it, and I don't want to pay for any power from the grid anymore. And that's easily said, and many people promise it, but it's extremely hard to deliver on this promise. And why? Well, it's because you have an energy system here in which a PV generator is coupled to the load required by the household, and a storage system, and the public power grid. And many of the stakeholders in this energy system vacillate considerably. The photovoltaic system vacillates in terms of its power generation. If there's a cloud covering the solar radiation, it drops down in terms of nominal value to 20%, 30%, and the load in the household that you require in terms of power changes dramatically. If you turn the oven on, suddenly you're talking 3 kilowatts by this electrical application that's suddenly required instantaneously. And once the oven is heated to the right temperature, the 3 kilowatt power output declines. And all of this happens at nearly the speed of light, and the public power grid balances this out almost at the speed of light too. So when you turn your oven on, 3 kilowatt hours are pulled out of the power grid. If you want to change that, you have to design your storage system such that as fast as possible it can provide this power to avoid having to get power from the public grid. And that's a challenge. And if, for example, you look at the measurements of the RWTH Aachen, who measured our product with various competitors as well, you can see that people really struggle with it. There are some products that require up to 10 seconds to cope with this kind of peak load. Now, we've tried as well as we can to make our system as fast as possible, and you have to have serious computational performance in terms of the circuitry, in terms of the control unit. I'm thinking of Mr. Schreiber, who's sitting in the front, Mr. Rentsch, who designed it. There's huge computing power necessary there, and it's included in there, and you need to have that if you want to have your system be so fast. There are a number of different processors. You could have set up a whole computer with this, and they're consistently measuring 126 parameters from the system with rates of up to 40 kilohertz. So that means they're processing 4 billion measurement data per day. Most are not stored, but some have to be. So that means 1.4 trillion measurement values being processed every year by this system. And the result of this is that we can do something that's pretty unique. Here you can see the response of the MyReserve storage system to a jump in load requirements. The red curve, you can see the rectangle there, that is the household requirements of power. So that would be, somebody's turned on the oven to bake something. At some point that gets turned on, and that then requires, you can see it, 10,500 watts of power from the storage system. And then a few seconds later, it's turned off, and then this power is freed up again. And the blue curve that you can see here is the response of the MyReserve storage system to these different requirements. And here you can see that within less than a second, this rectangular load jumps can be responded to. And why is that important? Well, because there are many consumers out there who, in quick succession, want this kind of load differential. So they turn the iron on, the oven on, the electric stove on. There are all manner of evil consumers out there who generate huge jumps in load requirement in quick succession. So with the iron, for example, it's every 10 or 15 seconds that you require this kind of load. And if you've got a storage system that needs 10 seconds to respond to a jump in load requirements, it could be that at that time, you're feeding in the 1.5 kilowatt hours. Once you've got them going, you're feeding them back into the grid. So there's just no point. This is how you have to do it properly. Obviously, the designers would like there to be no difference at all between the red and the blue curve here. And I'm sure we're going to continue to work to improve here. But certainly in this industry, this is absolute benchmark. We measure competitor systems, and I can tell you we've never met a better system than our own. Another thing we've learned from you is that service life and guarantee are important for you. You want to be able to say to your end customers, if you've got this system here, you won't have to worry about anything else. And if anything goes wrong, you've got a 10-year guarantee. SolarWatt is responsible for that. I'll be your first point of contact, but I'll be backed by SolarWatt. And it starts with the design of the product. If you want to deliver on a promise like that, right from the start, you can't do anything wrong. Every single one of your components has to do justice to this promise. And it starts with choosing the right lithium-ion cells. And you have to know that even the shape is decisive of your batteries. Lithium-ion cells are stressed, for example, if the electrodes in the cells, i.e. the plus and minus poles, are put under strong mechanical pressure. Like, for example, if you've got these films here, if they are bent quite dramatically, and in every coiled cylindrical cell that you know from your flashlights, that kind of battery, you can get them as lithium-ion cells. They are coiled, and that starts with a thin mandrel in the middle, and then you wrap all of these films around it until the cell is finished. And inside, you have very tight bending radiuses, something lithium-ion cells do not like at all, which is why the service life of these cylindrical cells is much worse than flat ones. So what that means is when you're selecting your cell, you have to make sure you've got the right shape, the right cycle stability. The form or the shape isn't the only aspect that's important with cycle stability, but it's important. And in California, for example, there is a company that uses only these round cells, cylindrical cells, which is why the service life is much, much shorter than that of ours. What can you see here in this diagram? This comes from the KIT, the Karlsruhe Institute of Technology, which tested all manner of different lithium-ion cells on the market. And what you can see here is that the number of cycles on the horizontal axis, which means every cycle is the cell is fully charged and the cell is completely discharged. And on the vertical axis, you can see the residual capacity of these cells. Lithium-ion cells age such that through cyclization, they lose capacity. And you'll know this from your mobile phone. When your mobile phone's a couple of years old, your battery doesn't last so long. And this statement, the battery doesn't last so long, goes hand in hand with the residual capacity of the cell no longer being 100%, but only 80% or 70% or 50%. And all of these cells that the KIT measured say super high quality lithium-ion cells. You can use this without any worries, but the differences are huge and it's totally intransparent. No end user and very few fitters can tell, looking at these cells from the outside, whether they are really high quality or whether they just say they are. Now, for a comparison here, the cell of our Californian competitor is around this area. And the cell that we used in the previous MyReserve product is here. And in this test, and they were very tough tests, they had 3,500 cycles. We would say in a household they would last for 4,000 cycles. Because in these tests, the cells are seriously stressed more than they would be in your average own home storage system. And the best cell that the KIT ever found before ours came onto the market is seen here on the right. It had 6,000 cycles, and now comes the cycle measurement of the new cell, which goes in the MyReserve Matrix, and it survived 7,000 cycles. So that means in a home it will last 8,000 cycles. This cell, through charging and discharging, can no longer be destroyed. It is really invulnerable. It only dies a natural death through old age. There's a second mechanism with which lithium-ion batteries die, and that is if you just leave them somewhere. Then in 15 or 20 years, they will at some point die a natural death, and this is the mechanism by which these new battery modules die. And this is not something you can achieve just by using the cell. And this is good news, because now you can tell your customers that it doesn't matter what load profile they have, whether they have heat pumps, swimming pool pumps that are constantly ensuring that the cell has to work around the clock, this cell will not break because of use. And the other good news for you is that you can work on the assumption that in 15 and 20 years, the cell will just die a natural old age death. There's no way around it. And so then in 15 or 20 years, you'll be able to sell them the next storage system. We wouldn't want them to last 50 years now, would we? And in 20 years, presumably, there will be a new generation of technology which will motivate the end user to buy even better battery systems. And the lithium-ion industry is using this. You know, the batteries that you have in your smartphone are designed to die after a certain a certain amount of time, not from one day to the next, but you notice it yourself. The operating duration basically gets smaller and smaller and smaller. So you need a new one. Now, ours is designed to last at least 15 years, more likely 20. And you can't have more than that. So we haven't made it worse artificially. This is simply the best that there is right now. Now, the operating strategy plays an important role here. If you charge in a not very useful way, you can prematurely age your battery. So this is an operating strategy that you find in almost all competitors' products. This strategy means that as soon as you have any surplus power from your PV system that you're not using in your home, you charge your batteries with it. And that means that in most private households, the battery by mid-morning at the latest is 100% charged, and then just sits there, charged 100%, waiting until load emerges in the household that motivates the battery to discharge. This is the normal strategy that the end consumer would expect. So early morning, they might have a look in their energy manager and see, oh, I've got surplus. Why isn't the battery charging? It should be charging. That's your normal expectation that you might have. But it's actually a silly way to operate this, because lithium-ion cells age prematurely if they are constantly fully charged, unless if they're only 80% charged, for example. The fuller the battery, the faster they age. So it doesn't make sense to always keep your battery fully charged. And by the way, this is true for your smartphone too. If you want to make your smartphone's battery last longer, pull it out of the plug as soon as it's fully charged. Don't just leave it charging overnight when it's already fully charged. And because we've understood this, because we have experts who work very closely with cell chemistry, we have a different charging algorithm that we've installed. And what it means is that we accept that in the morning there is indeed surplus power, and this is fed into the grid. So what we do is we charge the battery over lunch, which means that the lunchtime load peak is pulled out of the grid, which is useful for the grid. And this means that the battery is only charged when we can expect it to be discharged shortly afterwards. So the average is only 1/2 an hour that the battery is fully charged before it begins to discharge. And this makes the MyReserve Matrix does this in a learning manner. It learns from the behavior of the household. So it's constantly looking at how power is generated from the PV system. We can measure this because we have sensors in our system who can measure this. And how is the household load? We know this because there's a power sensor that measures this. And from all of these observations of the load generation and the load consumption, we come up with a forecast which says, okay, the battery will only be required at 4:30 in the afternoon. Then our system ensures that the battery is only fully charged at 4 p.m. So this is really the forefront of storage development here. You may have heard these things at various conferences. If you go to some of the technological conferences, this is something that academics and research institutes have assessed as the ideal strategy for commercial products. But in terms of actual commercial products on the market, you will only find this with SolarWatt, which is what makes testing these systems so difficult. Because you basically have to wait until the system has learned one of the load profiles. So on the first day, it behaves differently than the second day because it's learned something compared to the first day. And that this isn't just the way these things are designed theoretically, but the way they look in reality is something you can see here with this curve here, the SOC curve, which is read in percentage on the 1 scale. And here you can see that it's only late afternoon that the battery is being charged and its 100% fully charged state is reached. These are measurements from a real system that's with one of our customers. And then you get the exact state that I've referred to. Late morning, you're feeding into the grid. The battery isn't full, and it could happen that your customer phones you up and says, I'm really, really worried here that I've got all this PV power. The load in the household is low. The battery isn't full, but it isn't charging. So this is the downside of this smart charging system, is that it's so smart that it's very hard to explain it to your normal consumer if they notice it. I mean, there are people who don't even care about these things. Safety. Battery safety is an important issue and one that we have been worrying about for some time because we've been really concerned here because in Germany there were battery systems on the market. If you had one single mistake, that could lead to this battery bursting into flame. These were not products of SolarWatt, but they were products that were sold in Germany, and the KIT looked at this, and the VDI, the Association of German Engineers, jumped on this bandwagon, causing a lot of waves about this. But it meant that batteries in public households have to be 100% safe. And the awareness of this in the industry has increased hugely as a result. We've also said that there are seminars that you can look at on the SolarWatt homepage on the internet. We're very open about this. We share our expertise about battery safety with any competitor because we do not want this sector to be damaged in any way through products that have safety deficits. So perhaps enough on that. There's one more slide I'd like to show you, though, perhaps in this regard. In the SolarWatt MyReserve product, there's a battery management system which ensures that the lithium-ion cells are always kept in the safe operating range. There are two parameters that you have to bear in mind. One is the cell voltage and one is the cell temperature. And then there's an area that's green. And if the cells always stay in the green area, in the green range, you can have 8,000 cycles with this cell and nothing will go wrong. But if it once leaves this green range, whichever direction, you have to assume that the cell is damaged. And it is no longer safe to operate further. And that means that the battery management system, in this case, has to turn the system off such that it cannot be operated again. This requires a service technician or a fitter to come around and replace the defect battery module. And you have to work quite hard to achieve this. It all looks pretty simple here, but it does require considerable expertise. And you can rely on the SolarWatt products having had everything done correctly. There's not a single case that we've ever experienced where a single SolarWatt battery module became unsafe, although we did a great deal to try and provoke this. There were installation problems, problems with battery modules that crashed off the floor, all kinds of things that you could do wrong with these devices. We did do wrong with those devices, and I'm very, very happy to say that in the course of this development, at each step, we ensured that even gross maltreatment never brought these systems into danger. So that's what we can do actively to keep them safe. Passive safety is also very important, however. You can prevent by having the right system design that the battery module doesn't burst into flame, but you can't prevent the house around it bursting into flame. So what do you do if the house is on fire? And our concept is pretty straightforward here. It's all about solidity. Here you can see a battery module on the left-hand side installed in the smartphone of a Korean manufacturer, and the housing around it is just a thin layer of plastic, which is not at all able to cope with any kind of battery fire. There's no resistance to it at all. And this is why we decided not to build the lightest battery module in the world, but rather the safest one. And that means that there's a very solid aluminum housing around it, up to 13 millimeters thick, which means that it's not just very robust mechanically. You can drop it and it can bounce down the basement steps without anything happening to it. But you shouldn't actually install it when that's happened. But nothing's going to burst into flame even if it bounces down the cellar stairs, and you can't claim that for every module out there. And if it gets very hot, because the house is on fire, this massive aluminum housing will absorb a lot of the heat. It only heats up very, very slowly, and it takes quite a long time for this heat to be passed on to the cell inside. So that means you've got plenty of time to call the fire brigade, to put the fire out, and in most cases, it will indeed be the case that you've extinguished the fire before the lithium-ion cell has got so hot that it opens up and starts to burn. So this is a passive safety feature that you will only find in very, very few home storage systems. Most of the modules that you will find there only have a very thin sheet metal housing around them, or in some cases even a plastic housing. And when it comes to data transmission and communication, security is important. Why is that the case? If it doesn't occur to you immediately, why you have to be careful that communication with the battery is secure as well? Well, the reason is that essentially, if you have access to the battery management system, you could change parameters that ensure that the whole system works safely and make it unsafe. So the boundaries that I just described to you, the green box sets out certain temperature and cell voltage board boundaries, and they are set out in the software as important critical parameters. And if somebody were to manage to access a battery system via the internet, or worse, to attack lots of batteries at the same time, and could change these safety parameters, then they could ensure that maybe hundreds or hundreds of thousands of battery systems would be made unsafe. We don't even want to go there. And that's why we ensure that there's a physical barrier between the internet and the battery system. This is a diagram that you'll be familiar with from today's MyReserve products, looking at how they are linked to the internet. There's a CAN bus there from the automotive industry, which is very safe, very reliable. It goes to the power sensor, which measures whether power is being fed into the system or taken out of the system, goes from the AC sensor to the energy manager, from the energy manager to the internet. And you can go back and forth from the internet to the energy manager, but you can't go from the second CAN bus system to the battery system. Basically, you can't access the battery. So it's not just unlikely. There are various safety levels that you have, and there are people that say, oh, if the NSA or the Russian intelligence really want to do that, they can still access it. This is not the case here. They simply can't, because it physically cannot be done. Okay, and these are things that we have fed in on the basis of your suggestions and your wishes for the MyReserve Matrix, which we're going to show you now. What we've understood from you is that you want to offer your customers not just a product that you can stick 10 to 15 modules on, 2 battery modules, but you've said you want more, bigger PV strings, more storage capacity. We've heard you. The next thing we had then was MyReserve 800, up to 18 modules, 8.8 kilowatt hours. We thought, now our fitters will finally be happy. Couldn't be more wrong. They want more and more. 20 modules if possible. Storage capacity endless. Okay, here it comes. And this is the application area of MyReserve Matrix. 6 to 20 modules, new as well, because we couldn't have less than 10 before. Now you can do less than 10. Perhaps not that important for you. You want to sell more modules, so do we. But if there is a case where maybe they just want a carport to be serviced or a terrace roof and you can only put 6 modules on it, that will work now. And the capacity can go up till 12 kilowatt hours in the steps that you've already seen here. And the electrical power output is increasing. Peak output is 4 kilowatts of one of these towers, which means that without a problem, any heating pump can be run. So obviously you need quite a lot to get a heating pump going, but if you've got this kind of peak, you're on the safe side. And the consistent modular approach you've already heard about. The basic idea is make it as simple as possible. And this is a very important insight that we have learned from you. You have said to us it has to be simple. Keep it simple in the design, in the fitting, in the servicing, and we have tried to do this wherever we can. So this can be scaled up endlessly. Hopefully this year we will realize a project with the KIT where we'll have 1.5 megawatt hours on the basis of our modules. Now, you can tailor this system to the power needs, the wishes of your customers. If there's somebody who says, I want to have the biggest battery array that anyone in the neighborhood has ever seen, then you can give it to them. Or if you have somebody who says, I want to spend as little as possible and I only require a very little amount of power, can't you send me a system that only has 2 kilowatt hours of storage? Yes, you can. You just take one module, one MR pack, one MR command, and your customer's happy. Using the space available is another issue. We can hardly improve that. We thought long and hard about how we could make the volume even more compact. We know that you're working in very narrow utility rooms. There isn't much space there. There's not much wall space there. It's all very tight. And this is why you were saying, please make it smaller. We went from 223 liters volume down to 90 liters volume. And we can't really think of what else we could leave away. I mean, there might be a couple of centimeters here and there, but that's about it. You can install it very quickly. You will have seen that when Mr. Gutsch comes back from the press conference. Oh, there he is. He's back. Well, he's going to be talking to you afterwards a bit about how, as a trained fitter, you can install a system like this in the blink of an eye. You can expand it whenever you like. Even if it's been running 1 or 2 years, you can add more modules, and it is absolutely green and environmentally compatible. That's a standard in this industry. The MyReserve pack you'll be familiar with. It's changed a little bit to make it matrix compatible. So there's a MyReserve pack, which is compatible with the matrix. It can be used with the conventional products too, so it's upgradable and down, or you can use it with the old systems. The modules that have the MR500, the MR800, cannot be installed in a matrix, but the other way around it does work. Storage capacity is increasing from 2.2 kilowatt hours to 2.4 kilowatt hours. Same weight, same, even less volume. There's been a doubling of the cycle stability from 4,000 to 8,000 full cycles. And digital business modules, whether you want to sell regular power or whatever else you might want to do with this module, apart from your classic maximization of autonomy, you can do with this module. The MR command you've already seen. You've seen the efficiency diagram that I showed you earlier. We've made a real effort to make this system be as efficient as possible, and it responds in the twinkling of an eye to demands for power. We've replaced the semiconductor that we have with a silicium carbide semiconductor, which isn't free, but it gives us an efficiency advantage, which is why we've gone for it. It's compatible. There are various different interfaces. There's an open DC interface, which we haven't talked about too much, but that means that this system is prepared to feed in other energy sources as well. So these other energy sources might be power from a small wind turbine or a fuel cell, or it could be fuel from the AC grid as well. So this means that this system could charge the battery from the public grid. I mean, nobody would do that in Germany. It wouldn't make financial sense to do it, but who knows how things will develop in the future. We are basically ready for any possible developments of this kind. And there is a status indicator on any device that's Bluetooth capable. So that means even devices that are not connected with the internet or who don't want their storage batteries to be connected to the internet, you can have an app installed on your mobile phone, which means that the end consumer will get far more information from their storage system that they can have now based on blue blinking LEDs. So this is the whole range. These are the standard combinations that you can do right away. So you can offer 800 to 8,000 watt storage capacities of 2.2 kilowatt hours to 2.4 kilowatt hours with the new module. And this is just based on these two components. The matrix is just a normal patch cable, the way it's used here, and an internet router with various ISO internet capacity and devices, not a special cable of any kind then. And if, as a fitter, you have 2 MR commands and 10 MR packs, and you've got them ready to go, then it really doesn't matter what customer you have, you'll always have the right combination. So you don't have to think about whether you have to get a product from the small commercial line and order this or the home product. You've only got the two components, and if you've got sufficient storage, you can instantly deliver and install them the next day or the day after that. The next day or the day after. So I talked already about the use of space from 223 liters down to 70 liters. 70 liters are the modules themselves, but if you include the other components, then it's 90 liters too. And just as a comparison, this is a customer where there's an MR800 with an extension installed, 1.8 kilowatt hours output, 8.8 kilowatt hours, and you'd put 11.8 kilowatt and 33 kilowatt hours. So that shows you the kind of potential we're talking about with this modularity concept. There's just no point to give these customers these products, really. But if there's somebody who wants to have it, then of course we're happy to sell it to them, aren't we? And I talked about the concept of sustainability and the modularity concept, which means that you can add new modules in battery module housings. What color they're going to have at the end of the day, I cannot yet tell you. These are just examples here of what you could imagine. You can certainly work on the assumption that some of these concepts are in the drawer ready to go or in a laboratory stage already. This is the feedback we're getting from the market. And depending on the energy policy changes as well, we're going to have modules like these ones. Another important point that we've taken on from you, a feedback that we got again and again, is you said we want to be able to fit these and install these fast and simply, because we don't earn our money by spending many hours installing these, because the consumers are prepared to invest in a device, but they're not prepared to spend hours and hours for tradesmen's labor. And in the same time, you can install a number of different systems. So this is why we made it as fast and reliable to install as possible. You're going to get an error diagnosed through an extended self-test telling you what you need to do. If there is a problem, it would say exchange battery number 2. Module exchange can be done in 15 minutes. For somebody who doesn't know what they're doing, if Mr. Hinz sets the whole system in, how long do you need, Mr. Hinz, to do the whole system? 5 minutes. Okay. So once you've done it a couple of times, you can install a system like this, 2 battery modules, an MR command within 5 minutes, including cabling. But you have to have a substitute module stored in case you need to exchange an entire module. You've always got the right spare part with you, and you can expand after the fact if people want to. You just have an additional back wall and an additional module. Connectivity was a major issue for you. You wanted to see, or many of you wanted to see, standard connections. And here they are. These are the PV connector for the inverter and the PV module connector, the plug for the PV system. And there's just an ordinary plug for the 230-watt providers. There's another connection to connect you to the power sensor, all simple and standard. And here's something else we've got for you. Here, the data from the storage system is something that was very important for many of your end consumers. Today, what we have for you is that with your power sensor, you can connect to the energy manager with a CAN bus connection. And this will be possible in the future, too. You can continue to sell your end users energy manager with all of the functions that the energy manager has. At the same time, there's going to be a power data gateway, which will be standard for each MR command. It looks like this, just a little box. It only has 2 connections that are relevant for you. One is a USB stick for power, and the other is an RJ54 box for the consumer router. And you don't have to configure it. You just stick it in near the MR command within Bluetooth range. It will detect an MR command independently, connect by Bluetooth to the device. It will independently detect that there's a connection to the internet, connects to a database, and the data from the MR command from the storage system goes into this database, and with the appropriate interface, they can be accessed by the service technician, the fitter, the designer, or the end consumer, and any of these can look at the data and analyze it. I've tried this at home. 0 configuration, just plug and play. And you can do it with Bluetooth connection or with Wi-Fi connection to the customer. In the cases where you can't pull the cable, you can do it with Wi-Fi, connected to the Wi-Fi internet. But of course, then you do have to configure it. So you have to plug it into your laptop and ensure that Wi-Fi is connected. And then in the future, it's going to be the case that the functionality of this little box will already be integrated in the MR command. I can't tell you exactly when, but the decision we have made is that we're going to have a second little plug where you can connect it directly to the customer's router. Until then, you'll have this little box, which is included with every device. So what your end user sees are things like this. You've already seen it. They'll see that the equipment is working. The data from the MR command is on the smartphone of Ms. van der Ende. And this is the final design. This is what it's going to look like by Solar or just after it. We'll have it running like that. It will be available for iOS and Android, so it runs on Apple devices and on Android smartphones. The prerequisite is that there's a Bluetooth connection to the storage system. And you can do this without the internet. There doesn't have to be an internet connection. If the customer doesn't want internet or doesn't have internet or it's not working, they'll still be able to see their data. Now, for you as fitters, there are other options as well. On your app, you will be able to adjust things like the Wi-Fi setting, like I just talked about, or you can put the device in a test mode to see whether or not basic functionalities like charging and discharging are working. And there's a little button here called Update, which is the future of software updates. It's not going to go via an update stick, but rather via your mobile. Then return and recycling. This is always an annoying issue for many storage manufacturers. We're going very proactively into all of it. Of course, you have to be able to say to your end users what's going to happen when the batteries have reached the end of their service life. And obviously, as manufacturers, we will take these batteries. We've agreed with a joint returns system, the GAS. We've also thought about what's going to actually happen, though, with the components that will be returned to us. Many of them are still in good state. The cells may be older, they've maybe passed their service life, but the rest is in good shape here. And here you can see the cycle flows for the casing and electronics, everything except the lithium-ion. And you can see that 86% of the entire battery module can be reused into new battery modules, no less, which is a totally unique reuse rate in the industry. You won't find it anywhere else. Now, with the cells, it's a little bit more complicated because it's quite difficult at the moment to make new lithium-ion cells out of old ones. We can't, and no one else can either, and that's due to the fact that the number of lithium-ion cells that we have isn't too large. There are a number of cell manufacturers who are working on ways of making new batteries out of old ones. But until then, the metals in these cells, which are 41% roughly, can be used for other metal products. And the other things will have to be incinerated. So these are the options that we have with cells at the moment. But we're working with the GAS to find some good ways of recycling these, but we use everything else that we can use again so that we have as small a carbon footprint as possible. Something that we read in the headlines periodically, is lithium a problem? You can see on the left-hand side a little arrow. This is the amount of actual lithium in the storage system. And that answers many of the questions of whether there's not very much lithium. If all of Germany is equipped with home storage systems, the amount of lithium that we have in a battery module of this kind is so low that it really isn't a problem. So if we talk with the companies like in South America who are extracting lithium, they say there's plenty of lithium to ensure that the entire world car fleet is replaced with electrical vehicles and everybody has a home storage unit. No problem. Since Mr. Gutsch has arrived, what I was describing to you theoretically can now be done in practical terms. You can see he's very keen to get going. So this is your fictive solar fitter, Gutsch from Lüdinghausen Solar Technology Companies. He's going to show you how it's done, including cabling, including the side caps. You will see an actual fitting of this device, which would then work. So we start off with the MR command. You always install that first. Then you've got storage modules, and then MR pack number 1. See, this is a fitter who knows what he's doing, and it only takes 10 seconds. That isn't going to go through a quality test. Look, it's stuck on its edge there. Okay, start it over again. Now, you got it. That's great. And now we have all the cables. So I'm going to try and explain to you a little bit of what I'm doing so that Mr. Turm, who's responsible for the training sessions that we do, doesn't have to train you as hard. So this is all modular, all connected together, all these cables. It's not as pretty as it could be, but you won't see it later on, so it doesn't matter. And so what we do first is put the MR command module connected to these cables. And since I'm a man, I just can't seem to stick it in and talk at the same time. I think only women can do multitasking. Yeah, you have to basically plug them in. You can only stick them in one plug. There's only one right way round. And then it goes to the first battery module, then to the second module. And you can see the extendability because in the last plug, there's a little bridge there. And if you want to extend this system, it's really straightforward. You have an additional battery module there. This bridge is pulled, and then you just stick it in there. That's all you have to do. And now the cladding of the cables. The system would already work as it stands there. But of course, you know, there are both fitters and end customers and even designers who have an aesthetic point of view and they think, that doesn't look nice, all these cables hanging around. So this is why we decided to cover them up, and you have to screw 4 screws in to cover them up properly. And they basically screw it onto the module and ensure that the connection is sealed. Because if you look at these caps later, what you can see is that in the cap there's a seal. And that suggests what one of the next product development steps is going to be. This entire area here, once you've installed it, you can basically use it for outdoor use. So we're assuming that with a product like this at the IP44, we will pass the IP44 test. Okay, we're going to have to work on the lower area a little bit more, but up at the top there, it's all going to pass the outdoor use test. So this is what Mr. Hinz needs 5 minutes for. Being watched critically by Mr. Hinz. What do you think, Mr. Hinz? Are you happy with the way it's being done? Yeah? Oh, wait, where's that little cap? What did you do with it? I think Mr. Hinz said, we'll not bother with the cap. Okay, well, there is a little cap. Yeah, well, if there's no cap, I could do it in 5 minutes. With a cap, it might take 6. Okay, fair enough. Okay, now the AC connection. Of course, the PV cable and the inverter cable have to be plugged into. PV connector we don't have because we haven't actually got a rooftop PV system here. Why haven't we? Who's responsible for this building we're in, and why isn't there a rooftop system? You need to go away and think about that. And we haven't got an inverter hanging around, but essentially it's ready to go. It was an honor. And now, obviously, the PV cable's missing, but you could have installed it better than me anyway. And now, something new that we've never been able to do with MyReserve before. The fitter can now, via app, immediately check whether or not you've carried out the installation properly. You put it in test mode, and quite apart from the automatic mode, you can shift power around. There's basically a system that allows you to check the power. You can see whether it's charging, discharging whether all the basic functionalities are working, and that check will take about 5 minutes. And after that, you can leave your customer knowing that they will be happy because you were able to check with your app on the ground whether or not you've installed the system properly. That's right. Thank you very much. And that was an important thing that we took from you. You wanted to be able to see very clearly after you've installed the devices whether or not your installation was successful, yes or no. You were able to do that before, but now it's a lot easier. So this system basically is make it as simple as possible for our fitters. And here you can see in a nutshell that this is a system you can use for private households of all sizes and commercial enterprises as well. That might be a new field for some of you, for some not. Smaller, medium-sized industrial enterprises too. You can save money for the companies, for yourself as well, because the planning is reduced massively. You've only got these two components, and the installation, the service, all of it's a lot easier. Warehousing, keeping spare parts, training your staff will be made a lot easier as well, because all they have to do is understand these two components and the way in which you connect them. So that's pretty much all I wanted to tell you about the new system. Thank you very much for your patience and for your interest. You know, we're around. We'll be here all day and all evening. If you have any questions that you haven't asked yet but you'd like to ask us, approach us. You've met the designers. If you want to know something about certification, ask Mr. Timke. If you want to ask about power electronics, ask Mr. Trench or Mr. Götz or myself. Thank you very much, and now I'll release you to your break.